In this video, we will calculate the expected value and the variance of a binomial random variable. As a review, here are the formulas for calculating those. The expected value of a binomial random variable is calculated by multiplying n and p, where n is the number of trials and p is the probability of success. The variance, known as sigma squared, of a binomial random variable is calculated by n times p times 1 minus p, where n and p are those same things as before. So let's take these formulas and apply them to a problem. Suppose you perform an experiment which entails drawing 2 cards from a standard 52 card deck. You look at them and you put them back and shuffle. If this experiment is repeated 25 times, how many times do you expect to draw 2 cards of the same suit? So let's define what n and p are, because we're going to need that to calculate the expected value. So n is the number of trials. How many times are we doing this experiment? 25. P is the probability of success. So in this example, a success is what we're interested in. 2 cards of the same suit. So now we need to calculate the probability of drawing 2 cards of the same suit. So we have card 1 and card 2. Now card 1, we have no specification on. We could draw any of the 52 cards out of the 52 cards, which you may be thinking, that's just the number 1, and that's correct. So that doesn't actually help us define our probability, because that first card helps us determine that second card probability. So now for our second card, if we want it to match that suit, there are now 12 different cards left in that suit, and there are 51 cards left in the deck because we want the suit to match. And remember, there's 13 cards of a certain suit or denomination, and those are things like hearts and clubs. So now, basically we have the number 1 times 12 over 51, which is just the probability 12 over 51. So now for the expected value of doing this 25 times, we take n times p, which gives us 25 times that probability 12 over 51. And we have to round and we get 5.88. So in 25 times, we expect that about 5.88 times, or almost 6 times, that we draw 2 of the same suit. Let's interpret that. In 25 draws, we expect, I'll say 5.88, or almost 6, to be cards from the same suit. Now let's calculate the variance of this experiment. So using the formula that we're given, we need n and p and 1 minus p. So we have all of these variables that we need already, so we can plug them in. So sigma is equal to n, which is 25, times p, which is 12 over 51, times 1 minus 12 over 51. So now we plug this into our calculator, and we get about 4.99 is the variance. Let's try one more example. Jill gets a right answer 92% of the time. If she takes 3 exams, what is the variance? Round to the nearest hundredth. Okay, so we're looking for variance here, so we need n and we need p. So n is our number of trials, which is 3. P is our probability of success, is what we're interested in, which is getting the answer right. So 0.92 when I transfer that to a probability. And then the variance is sigma squared is equal to n times p times 1 minus p. So 3 times 0.92 times 0.08, or 1 minus 0.92. And when we multiply all these together, we get rounding 0.2208 is the variance. And the variance is just a measure of spread, or how spread out numbers are from the mean or from the expected value.